Welcome to step 11. Today you're going to learn how to solve one-step division equations. Sorry, that was my son saying good night. Good night, Dylan. Sorry about that. Let's go ahead and learn how to solve one-step division equations. Okay, when do you think we could use division equations to solve equations? Well, some examples, and I'd like you to write these down, are division equations. Okay, you write what I write, please. These notes should be loaded into GoodNotes, obviously. Division equations can be used to find the total length of something when you know the length of a piece and the number of pieces Another way you can use division equations is division equations can be used to find the actual size of something when you know the size of the model and scale. So keep those in mind as situations when you might want to be able to use division equations to help you solve a problem. Okay, let's make that a little bit bigger. Okay, press pause until you've gotten all of this written, and then you should go on to the next screen when you're ready. Okay, ooh, Jolly Ranchers, that's some of our favorite candy, I know. Okay, so you should see 6 sets of 5 Jolly Ranchers. Yummy. Let n, I'm going to underline that, let n represent the total number of Jolly Ranchers. What multiplication equation can you write to show the total number of candies? Well, if n represents the total number of candies, we would write a multiplication equation that had an equals n, right? And how many groups are there? 1, 2, 3, 4, 5, 6 groups. So there's 1, 2, 3, 4, 5, 6 groups. So we would write 6 times how many in each group? How many Jolly Ranchers are in each group? Let's see what we've got here. Since there are 5 Jolly Ranchers in each group, we would write 6 times 5 equals n. Now, the next question is, what division equation can be used to represent this situation? Well, let's use an example that we can all handle. Let's say if we said 6 times 5 equals 30, you know that division is the opposite of multiplication, so we could say 30 divided by 5 equals 6. So let's use that same logic to try to figure out how we would rewrite this equation. We'll use the exact same thing that we did here. 30 divided by 5 equals 6, so n divided by 5 must equal 6. So we would say n divided by 5 equals 6. Some of you might be saying, why did you just use a fraction? But remember, fractions are just division problems in disguise. So I can write it like that. N divided by 5 equals 6. Okay, what division equation could you write if there are 8 items in each of 3 groups? Okay, you could actually draw a group here. It says imagine that you have an unknown number of items that are separated into 3 equal groups. You can draw items if you would like to help you visualize. So let's just say that if we had 8 items in each of 3 groups, so we would want to write, let's see if I can find something good to use. Okay, let's do 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 3 groups, each one having 8 items in it. What division equation could you write if there are 8 items in 3 groups? Well, if we didn't know how to count and we just wanted to make up an equation, we would say that our total would be, let's call it T for total, T divided by the number of groups, which is 3, equals 8 pieces. Okay? We happen to know that there are 24 items here, so if we had solved this, 24 divided by 3 does equal 8, so it makes sense. Okay, when you're ready, go ahead and go to the next page. Okay, now let's use something called a bar diagram to help us. Okay, here's our problem. Leslie spends 5 Okay, to solve a multiplication equation, we used division. What operation would you use to solve a division equation? Think about undoing it. Okay, undo it. We always use the opposite operation. So if we use division to solve multiplication equations, we should use multiplication to solve division equations. Okay. How can a over 3, or a divided by 3, be rewritten as the product, multiplication, of a fraction and a variable? In that case, you should know that a over 3 is the same thing as saying 1a over 3, which can also be written more neatly as 1/3 a. Okay? What do you need to multiply 1/3 a by to eliminate the fraction? To get rid of the fraction, I'm going to write it over here, 1/3 a. To get rid of it or cancel it out, you should think about your multiplication of fractions unit and dividing. If you're undoing multiplication, you have to divide. And remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So we would multiply by the reciprocal, which is 3 over 1. It cancels out beautifully. Everything cancels out, and we're left with our variable a all alone. Okay? If you multiply 1/3 a by 3, what do you need to do to the other side of the equation? Remember, equations are like scales. They must stay balanced. So if we multiply by 3 on one side, we need to multiply by 3 on the other side. Okay, you try. Solve p over 7 equals 5. Please think about what we just talked about. P over 7 equals 5. You might want to start by rewriting this as 1/7 p equals 5. Now you need to get rid of the 1/7 next to the p. So you need to undo the multiplication by using division. Now remember, division of a fraction is like multiplying by the reciprocal. So press pause for now until you've tried and then check your answer. Welcome back. Hopefully you've checked your answer and you decided that you should multiply both sides by 7 over 1. Always do the same to both sides. Never leave your scale unbalanced. Okay, these cancel out and you're left with p equals 7 times 5, which is 35. Obviously, we would want to check our answer, so we would put 35 in for p. 35 divided by 7 should equal 5, and it does. Let's give ourselves a star. Good job. Okay, go ahead and go to your last page. Okay, the multiplication property of equality. If you multiply each side of an equation by the same non-zero number, the two sides remain equal. That's called the multiplication property of equality. That just means that if you multiply the same number on both sides of an equation, you get the same answer. So here's some examples. Using numbers, 3 equals 3, obviously. 3 times 6 equals 3 times 6. 18 is 18. Whatever we did to one side, we had to do to the other. Now looking at algebra, it's the same thing. If I have x over 4 equals 7, that is the same thing as saying x over 4 times 4 equals 7 times 4, because we times both sides by 4, which leaves us with x over 28. Okay, hopefully that makes sense. Let's go ahead and do a couple of examples of solving one-step equations. Okay, let me give you a couple of examples. Okay, add a page to your notes, please. Let's see, I think there we go. Okay, so let's add a page to your notes and let's solve w over 6 equals 35. Okay, let's rewrite it as 1/6 w equals 35, just so it's a little more obvious what we should do. To get rid of the 1/6, we should multiply by the reciprocal, 6 over 1, and we should do that to both sides. Okay, this cancels out. We're left with W equals 35 times 6. 6 times 5 is 30. 6 times 3 is 18, plus 3 is 210. Now let's test our answer. We should always test our solution to see if we are correct. Put the 210 in for W. 210 divided by 6 does in fact equal 35. You can always check with your calculator if you like. So we get a check there. Good job. Let's go ahead and do one more. Maybe more. One, maybe two. This one. S over 4 equals 22. This time I'm not going to actually rewrite the problem. I'm going to have us just times it by the reciprocal. Whenever you see this fraction, it is read S divided by 4. If you hear the words divided by, that means you need to multiply to get the variable by itself. So you need to multiply by 4 on both sides. Okay, so we times by 4 on both sides. These cancel out. You are left with S equals 88. Plug it in to make sure that it is correct. 88 divided by 4 does in fact equal 22. Good work. Okay, now let's do, I promise you, this is actually the last one. Well, maybe I'm going to do a couple more. I keep changing my mind. Nathan picked a total of 60 apples in 1/3 hour. Write and solve a division equation to find out how many apples Nathan could pick in an hour. So let's write this down. Nathan picked a total of 60 apples in 1/3 hour. Write and solve a division equation to find out how many apples could he pick in 1 hour. How many will he pick in 1 hour? Okay, the way our division equation should look is A, let's use A for our variable for apples, A times 1/3, because it says of, whenever you see the word of, that usually means multiply, 1/3 of apples equals 60. You could have also written it as, let's see, or you could have written it as A over 3 equals 60. We will times both sides by 3 to get our solution. This cancels out, and we are left with A equals 180. If we check it, 1/3 times 180 does equal 60. Good job. Okay. Let's do one more, this time with a decimal, and this time I really promise it's the last one. Okay, R over 8.5 equals 16, or R divided by 8.5 is equal to 16. Please remember that the fraction bar, I'm going to write this over here because it's so important. Fraction bar means divided by. That is really important. Okay, so when we see divided by, that means to get rid of it, we have to multiply. Decimals don't change the process. We just times it by, oops, I don't like that. We just times by the decimal. Okay, so these cancel out just like any other numbers would, and R equals 16 times 8.5. So let's go ahead and write that over here. 16 times 8.5. Hopefully you have not forgotten your decimal multiplication rules. Okay, 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. Placeholder. 8 times 6 is 48. 8 times 1 is 8, plus 4 is 2, so 12. And we have 0. 8 plus 8 is 16. 3, 1, and then hopefully you remember there's one place after the decimal, so that means we need to bump our decimal over 1 here, and our final answer is 136. We should plug that in to make sure that it is correct. 136 divided by 8.5 should equal 16. If we plug that into our calculator, we will find out that that is correct. Good job. Hopefully this makes sense to you, and if you have any questions, please don't hesitate to ask, and good luck on all your practice problems and your checkpoint. Bye for now.